Up until now, we have only taken the derivatives of functions in the form of y equal to some function of x. That's known as an explicit form. So we use implicit differentiation when we want to take the derivative of relations that cannot be easily expressed in function form. So here an example. In this example, we have a conic section, a circle with a radius of 3. And I want us to find both dy dx and dx dy. So notice whatever term is on the bottom is the variable we are taking the derivative with respect to. So first, if I'm using x squared plus y squared equals 9, the first one, dy dx, wants us to take the derivative with respect to x. So that would be d dx of x squared plus d dy of y squared, but then we have to multiply that by chain rule, the derivative of y with respect to x, because if you notice, if these cancel, we're left with d dx, right? So we are taking the derivative with respect to x. So now we have equals d dx, the derivative with respect to x of 9. So now the derivative with respect to x of x squared is 2x plus the derivative with respect to y of y squared is 2y multiplied by dy dx equals the derivative of a constant, which is 0. So now I can isolate dy dx. I'll have 2y dy dx equals negative 2x. And then if I divide each side by 2y, I have dy dx equals negative x over y. So now for our second part, I want to take the derivative with respect to y. So now we're doing the same idea, but now we want the derivative with respect to y instead of with respect to x. So same formula. Now we have d dy of x squared, but I'm going to, d dx of x squared, but then I have to multiply by chain rule dx dy because we're taking the derivative with respect to y, plus d dy y squared equals the derivative with respect to y of 9. So the derivative with respect to x of x squared is 2x multiplied by chain rule dx dy plus the derivative with respect to y of y squared, which is 2y, equals 0. So now I can isolate dx dy. 2x dx dy equals negative 2y. So dx dy equals negative y over x, which is true. It's the reciprocal of what we just found in the first part. But ultimately, we want to show that you can take the derivative with respect to more than one variable. It is not always x.